The Interceptor Barricade is now operational in the Rio Las Vacas, Guatemala, successfully capturing plastic waste before it reaches the Caribbean Sea. Since the end of April, the ocean cleanup has extracted over 850,000 kilograms of debris from the river as of June 13th. Early results are promising, with the system already stopping large volumes of trash. However, the true challenge lies ahead with the coming rains, which often bring massive surges of plastic. Cleantec Infra Pvt Ltd is pioneering a mechanized solution to India's canal and river pollution woes with its floating trash skimmer systems, specially engineered vessels that scoop up floating litter before it harms waterways. Founded in December 2010 in Delhi, Cleantec Infra has since deployed its floating skimmers across numerous Ganga and Yamuna locations: Varanasi, Kanpur, Allahabad, Prayagraj, Mathura, Delhi, Patna, Sahibganj, and even in canals, urban lakes, and drains across multiple states. Their core technology includes hydraulically controlled gates leading trash onto conveyors, which transport waste to shore for disposal. These systems are Make in India built, handling 3 to 30 cubic meters per unit and performing 10 to 20 loads per shift. Cleantec operates under two business models: selling equipment plus O&M services, or offering turnkey cleaning contracts. With over 50 projects in 18 states, they manage some 60 machines with 150 field staff and 30 factory/office employees. During religious mass gatherings like Kumbh and Magh Melas in Allahabad, Nashik, Rajahmundry, Cleantec active deployment ensured river surfaces remained clear amidst heavy crowd-generated debris. Under the Namami Gange mission 2017-20, their skimmers at Patna and Sahibganj collected floating waste daily for 3 years, including plastic bags, bottles, flowers, and dead bodies. In early operation alone, they removed approximately 700 tons, averaging 10 to 12 t per day. Their machines have also cleaner Sabarmati River, Ahmedabad, Mithi River, Mumbai, Godavari, Yamuna drains in Delhi, Hussain Sagar Lake, Hyderabad, and more. Recognition has arrived. International outlets, Tech Insider and Futurism, spotlighted Cleantec's floating trash collectors. Their operations echo global trends like interceptors and smart barriers, but are adapted for Indian waterways. Today, Cleantec skimmers roll through canals and riverine systems, intercepting plastics, bottles, religious waste, hyacinths, household refuse, even animal remains, before they sink or flow into broader ecosystems. As urban waterways litter canals like Vijayawada's Bandar, Rives, and Elleru, with nearly 5,000 t removed in just Q1 2025 alone by local municipal corp, Cleantec's approach shows what mechanization can achieve when scaled nationally. Facility where mixed recyclables are sorted, cleaned, and prepared for reuse. The bolograph drum feeder evenly distributes materials onto conveyors, eliminates clumps and blank spots, and removes the need for wheel loaders. The system eliminates the need for additional wheel loaders by automating material flow. It opens plastic bags, ensuring even distribution with no clumps or blank spots, maximizing efficiency and consistent processing. Large non-recyclable items removed early to prevent equipment damage. The Dulevo triple-deck OCC screen efficiently separates large cardboard OCC from mixed recyclables using rotating discs and tiered screening levels. Breaks glass into smaller pieces for easier separation and sorting. The Wall-Air system separates broken glass into 4 clean fractions, removing contaminants like film, food packaging, and small cardboard pieces. Food packaging, small boxes, and plastic film often contaminate recyclables and require specialized sorting to separate them from paper and plastics. Old newspapers, trash, film plastics, small OCC, old corrugated containers, and containers are common materials processed at a material recovery facility, MRF. Old newspapers are valuable paper recyclables that need to be carefully separated to maintain quality for repurposing into new paper products. Trash, including non-recyclable items, must be identified and removed early to prevent contamination and damage to recycling equipment. Film plastics, such as plastic bags and wraps, are challenging to process because they can tangle in machinery. Specialized equipment like bag openers and film separators are used to free and isolate these materials. Small OCC pieces and containers often mix with other recyclables, so screening systems like the Dulevo triple deck and glass breakers help to sort them efficiently. Proper separation ensures higher quality recycled materials and reduces landfill waste. The backer inline overbelt magnet is a critical component in modern material recovery facilities, MRFs, designed to efficiently remove ferrous metals, such as steel cans, nails, and other magnetic debris, from the recycling stream. This system is typically installed above conveyor belts and can be configured in two primary orientations. The backer eddy current separator is a vital piece of equipment used to separate non-ferrous metals, such as aluminum and copper, from mixed recyclables. It operates by generating a rapidly changing magnetic field that induces electric currents in conductive metals, creating a repelling force that ejects them from the material stream. This process efficiently isolates valuable metals without contamination. Installed after ferrous metal removal, the separator helps improve the purity of recycled materials, protects downstream equipment, and increases overall sorting accuracy and recovery rates in recycling facilities. Plastic bottles, especially those made from PET, polyethylene terephthalate, are widely used and recycled in Europe. Every year, billions of these bottles are bought and discarded. Once collected, PET bottles are taken to sorting centers, where they are cleaned, sorted, and compressed into bales for easy transport. At recycling plants, the bales are processed through several steps. Metals are removed by magnets, labels and glue are washed away, and manual sorting ensures only PET materials continue. The bottles are then ground into flakes, which are further sorted by color and material. These flakes are dried, melted, and filtered before being formed into spaghetti-like strands, then cut into pellets. These pellets undergo decontamination to become food-safe and are shipped off to manufacturers to create new bottles. This closed-loop recycling system helps reduce waste and supports sustainable use of plastic by continuously remaking PET bottles from recycled materials. The city of Edmonton has developed a comprehensive and industrial-scale composting process to handle residential organic waste, which comprises nearly half of the city's total waste. This process converts materials like food scraps, grass clippings, leaves, and even non-recyclable paper into nutrient-rich compost that benefits soil health and agricultural productivity. The process is designed to maximize waste diversion from landfills while producing a valuable end product. The journey begins with curbside waste collection, where residents place all household waste, both organic and inorganic, into their garbage bins. These materials are transported to the Edmonton Waste Management Center, specifically to the Integrated Processing and Transfer Facility, IPTF. Here, the waste is first tipped onto a large concrete floor. Front-end loaders push the waste into piles for initial inspection. Oversized or clearly non-compostable items like furniture, large metal pieces, or carpets are removed manually. The material then passes through trommel screens, which are large rotating drums with holes that allow smaller compostable materials to fall through, while larger non-compostable items are screened out. An electromagnet is used to remove any ferrous metals, and recyclables such as cardboard are also separated for recovery. The organic-rich material that remains is conveyed to the Edmonton Composting Facility. Here, it is combined with biosolids, treated organic materials from wastewater, in large mixing machines or enormous rotating tubes the size of hockey rinks. This step initiates the composting process by homogenizing the mixture and starting the biological breakdown of organic matter. The material slowly moves through the tube over 2 days, during which microbial activity begins to break down the waste. Following initial mixing, the semi-composted material enters the aeration hall, a massive enclosed area where the majority of composting takes place. In this stage, the compost is arranged in large piles or bays, where it stays for about 1 month. Augers, which are large screw-like machines, continually turn the compost to introduce oxygen and maintain appropriate moisture levels, key elements for efficient decomposition. After a month in the aeration hall, the compost undergoes further screening to remove any remaining contaminants. It is then moved to an outdoor curing site, where it remains for an additional 5 to 6 months to allow the compost to fully mature and stabilize. This curing stage ensures the final product is free from pathogens and has the right nutrient profile. Once the curing process is complete, the compost is ready for market. It is sold or distributed for use in agriculture, landscaping, and gardening. The end product not only enriches the soil with nutrients, but also improves its structure, moisture retention, and aeration, making Edmonton's composting process a model of sustainable waste management and environmental stewardship. Cleantec Infra undertook a turnkey cleaning operation to tackle rampant aquatic weeds, primarily water hyacinth, overgrown across the 900-acre expanse of Bellandur Lake in Bengaluru. Employing their aquatic weed harvester, a robust underwater lawnmower, they mechanized removal of submerged, emergent, and floating vegetation using a forward conveyor system and a trio of cutter bars, 1 horizontal and 2 vertical. During the first 6 months, this fleet, including weed harvesters, pontoon excavators, and JCBs, cleared nearly half the lake, hauling hundreds of tons of biomass to a composting facility for eco-friendly recycling. The harvester's customizable design, storage up to 30 cubic meters, 15 to 20 loads per shift, allowed it to accommodate Bellandur's scale efficiently. This mechanized approach offers immediate ecological benefits, clearing navigation paths, reducing nutrient load, benefiting dissolved oxygen in fish, and mitigating flood risk by preventing sediment buildup. Unlike herbicidal methods, it minimizes chemical impact while enabling physical biomass recycling into compost. The Amphibious excavator has played a crucial role in the desilting of the upper and lower lakes of Bhopal, ensuring improved water storage capacity and ecological health of these vital water bodies. Specially engineered to operate in marshy and soft terrains, this machine is ideal for lake restoration projects. Its expandable, track-mounted pontoons enable it to float on water and navigate soft or submerged surfaces with ease, allowing it to access areas where conventional equipment cannot operate. With an impressive 50-foot reach, the excavator can cover wide sections of the lake, enhancing operational efficiency. The presence of 2 stabilizing spuds ensures that the machine remains fixed in one position while dredging, preventing drift due to water currents or machine motion. This stability allows for precise desilting and minimal disruption to the surrounding ecosystem. Additionally, the retractable pontoons make it easier to transport the machine over land and provide added stability during operations. By removing accumulated silt and debris, the amphibious excavator helps restore the lake's depth, improve water quality, and support biodiversity. In an ambitious effort to halt plastic pollution at its source, the ocean cleanup deployed an Interceptor Trashfence in one of the world's most polluting rivers. The mission: stop the flow of plastic waste before it reaches the ocean. At first, it worked. The fence held back a surging wave of garbage, a literal trash tsunami. As floodwaters swelled, the immense pressure of trash and water overwhelmed the structure. Poles bent under the strain, sections of the ground washed away, and large amounts of plastic slipped past the weakened fence. Despite the failure, the team remained optimistic. Though the trash fence couldn't stop this flood, it delivered critical insights. The ocean cleanup's broader mission involves intercepting plastic in the 1,000 rivers responsible for 80% of ocean plastic pollution. The Interceptor Trashfence is a scalable tool in this fight, aimed at closing the tap before waste ever reaches the sea. With every setback, adjustments are made, because the stakes are massive. Millions of kilograms of plastic flow into the ocean yearly. While this attempt didn't succeed, it's a step toward the goal, preventing up to 20 million kilograms of plastic annually from reaching the Caribbean Sea. The war on ocean plastic is far from over, but the fight continues. The Dulevo 6000, fitted with a dedicated weed brush attachment, offers an efficient and eco-conscious solution for weed removal in urban environments. Designed for municipalities and city maintenance teams, this street sweeper combines mechanical power with precision brushing to eliminate weeds from paved surfaces, sidewalks, gutters, and curbstones. Unlike chemical herbicides, which can harm surrounding plant life, pollute water sources, and pose health risks, the Dulevo 6000's mechanical weed removal process is entirely non-toxic. The robust rotating weed brush targets and removes vegetation at the root level, loosening soil and debris while preserving the integrity of the surface. This ensures not only cleaner public spaces, but also longer intervals between maintenance cycles due to the thoroughness of the process. Equipped with high-capacity suction and filtration systems, the Dulevo 6000 also captures the dislodged weeds, dust, and debris immediately, preventing the spread of seeds and minimizing airborne particles. This makes it ideal for high-traffic pedestrian zones, parks, and residential streets where cleanliness and safety are paramount. Incorporating weed brushing into routine sweeping schedules boosts operational efficiency and reduces the reliance on manual labor or multiple passes with different machines. Ultimately, the Dulevo 6000 with the weed brush attachment provides a sustainable, cost-effective, and high-performance solution for maintaining urban cleanliness and aesthetics without compromising environmental values. Established in 1998, Complete Drain Clearance has built a solid reputation as a trusted provider of drainage services, operating exclusively within the railway industry. Over more than 2 decades, the company has become a key partner in maintaining the integrity and safety of the UK's rail infrastructure, specializing in drain maintenance and clearance services, tailored specifically to the unique demands of the railway environment. From its inception, Complete Drain Clearance recognized the critical importance of reliable drainage systems in ensuring the operational efficiency and safety of railway lines. Poorly maintained drainage can lead to track flooding, embankment instability, and long-term damage to critical infrastructure. Understanding these risks, the company developed a focused service model aimed at preventing drainage failures before they impact rail operations. Operating exclusively within the rail sector, Complete Drain Clearance offers a range of specialist services, including high-pressure water jetting, CCTV drainage surveys, root cutting, desilting, and vacuum excavation. These services are delivered using industry-leading technology and carried out by highly trained operatives who understand the complexities and safety requirements of working in active rail environments. All work is conducted under strict compliance with Network Rail standards and regulations, with teams qualified under the Sentinel scheme and fully equipped to work on or near the line. A key differentiator for Complete Drain Clearance is its singular focus on the railway industry. Unlike more generalist drainage contractors, the company's expertise lies solely in rail-related drainage challenges. This narrow but deep focus enables them to deliver efficient, reliable, and cost-effective solutions tailored to the unique needs of rail asset managers and maintenance contractors. Whether it's clearing historic blockages along rural branch lines or undertaking large-scale preventative maintenance along busy main lines, their teams bring experience, precision, and commitment to every project. The company has also invested heavily in its fleet and equipment to meet the diverse demands of rail drainage maintenance. From off-track vehicles fitted with jetting and vacuum systems to rail-accessible machinery designed for work in hard-to-reach locations, Complete Drain Clearance ensures that no drainage issue is beyond reach. Their mobile units are equipped to respond quickly reducing disruption to rail services and ensuring minimal downtime during scheduled possessions or emergency interventions. Over the years, complete drain clearance has earned the trust of major rail clients and contractors across the UK, thanks to their consistent delivery, focus on safety, and ability to adapt to the evolving needs of the railway. As the industry faces increasing demands due to climate change and higher passenger expectations, effective drainage maintenance becomes more crucial than ever. Complete drain clearance continues to meet these challenges head-on, offering specialist expertise that helps keep the nation's railways running smoothly and safely. With over 25 years of dedicated service to the railway industry, Complete Drain Clearance remains a dependable partner in rail infrastructure maintenance, working quietly but critically behind the scenes to ensure that Britain's trains stay on track, rain or shine. For nearly 30 years, Kent Carlson has been a driving force behind modernizing sewer maintenance in Los Angeles. After serving as a Navy machinist, he joined the City of LA's Bureau of Sanitation. He was recruited specifically to address lagging progress in the collections division, bringing new tools and standard processes to reduce sewer overflows and adapt to drought conditions. Carlson encouraged a shift from brute force cleaning to technology-driven methods. He pioneered low-water use nozzles to conserve precious California water and introduced hydrojetting and robotics to efficiently handle blockages. His team also designed bespoke attachments, like rotatory root cutters, saw-equipped nozzles, and tailpiece tools, all engineered to meet the specific diameters and needs of LA's system. A standout innovation is the integration of CCTV-equipped drain bots. These compact robots provide detailed dome-style views of the pipe interior, allowing crews to accurately diagnose issues, e.g., roots, protruding pipes, mineral scale, before cleaning. This minimized unnecessary digging and enhanced safety. No more full immersion inspections. Under Carlson's leadership, aggressive maintenance protocols, combining high-pressure hydrojetting, 2,000 to 5,000 psi, with mechanical rodders, were formally adopted into the department's SOPs, aligning with EPA's CMOM guidelines. This nearly eliminated sanitary sewer overflows while restoring full pipe capacity and reducing maintenance costs. Today, Carlson's work supports maintenance across approximately 6,500 miles of city sewer lines, some dating back to the 1880s.